Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, IIT-Jam exam, Jest, Tifr and other exams related to physical science. Okay, so before starting the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my classes which are free of charges and are going to help you to crack the examinations related to physical science. Okay, so this is the in this lecture we are going to solve the PYQs of 2019 CSIR Net Physical Science. Okay, so this is the fourth part of the series. Okay, fourth lecture of the series in which we are solving 2019 CSIR Net Physical Science PYQs. Okay, so I'm going to start now with question first. First question is, meanwhile, let me just check, am I audible or not? This is important. So I'm going, yes, I'm audible. Okay. Okay, question is, it is a question from optics. Okay. The question is, two coherent plane electromagnetic waves, two coherent plane electromagnetic wave, plane electromagnetic waves of wavelength, electromagnetic waves of wavelength, 0.5 micrometer both have the same amplitude, both have the same amplitude, and are linearly polarized, linearly polarized along the z direction, fall on the y equal to 0 plane. Their wave vectors, their wave vectors k1 and k2 are as shown in the figure, are as shown in the figure. Okay, I'll draw the figure for you. If the angle theta, if the angle theta if the angle theta is 30 degree, the fringe spacing the fringe spacing, that is fringe width, right? The fringe spacing of the interference pattern of the interference pattern produced on the plane is, options are 0.0 micrometer, option B is 0.29 micrometer, option D is 0.58 micrometer, and option D is 0.5 micrometer. Okay, this is the question. I'll draw the figure as well, then the question will be clear to you. Okay, this is x-axis, this is y-axis. Okay, this is the wave vector. These are straight lines, guys. This is the wave vector. Okay, this is k1, this is k2, vector, or like k1, and these are straight lines. Okay, there is difficulty in drawing, but consider these are straight lines. Okay, so these are the wave vector, and this is the y plane, this is x plane. Okay, this is the figure which is given. Okay, and this angle is theta, and this angle is also theta, and value of theta is 30 degree. Okay, so I'll read the question for you. Very good question of interference. Question is, two coherent plane electromagnetic waves of wavelength. So there are two coherent electromagnetic waves whose wavelength is 0.5 micrometer. Both have the same amplitude and are linearly polarized along this z direction. Okay, so they are linearly polarized along this z direction. Fall on y equal to 0 plane. Okay, so this is y equal to 0 plane. This is y equal to 0 plane. These are two waves. The wave vector is k2, wave vector is k1. Okay, this is the given figure is. I'm just checking with the connection. Okay, okay. So I'll start. So first we'll find out this one, right? The wave equation. Okay, these are the wave vector, right? These are the waves. The wave vectors are k1 for this, k2 for this. Okay, so the equation is going to be, electric field vector is going to be E1 for first is we know that is all are z direction, right? Z cap, electromagnetic equation, this is wave equation we are writing. So this is A e to the power iota omega t minus k1 dot r. K1 dot r is the position vector, and E2 vector is going to be E2 vector for this. Okay, electromagnetic wave equation, the E2 vector for this K2 vector, this vector, right? This one, right? So this is going to be z cap. A is also there. The amplitude are same, right? Z cap A e to the power iota omega t minus k2 dot r. Okay, this is the electric field vectors, right? The wave. Okay, electromagnetic wave equation, right? Now we know here from this, right? This is the normal. Okay, and this angle is theta. So just wait, let me just check. This angle is theta, right? So the component along this direction and component along this direction, you find. Okay, so k1 vector, k1 vector for this vector we are talking about, this k1 vector, right? For the k1 vector, this is along this is going to be k1 cos theta, along this is going to be k1 sin theta, right? And direction is this. Okay, so this is going to be k1 vector is going to be k1 sin theta x cap minus k1 cos theta y cap, right? And k2 vector is going to be minus k1 sin theta. Here, since k1 vector modulus of k1 equal to modulus of k2. Okay, okay, they are coherent waves. Okay, coherent electromagnetic waves. Okay, these are the equations for electromagnetic equation, right? So this is going to be k2 k1 sin theta because k1 mod k1 equal to k2, right? K1 equal to k2, so we can write k1 sine theta x cap minus k1 cos theta y cap. Okay, these are the vectors for this one, right? Along this it is cos theta, k1 cos theta, along x-axis k1 sin theta. Similarly, along k2, along x-axis k2 cos theta, and along x-axis k2 sin theta, right? Okay. Okay, so now this is the one k1 k2. Now we'll find the value of k1 dot r. Okay, so r we know, r equal to x I cap plus x cap. Here we'll write x cap x cap plus y cap plus z cap, position vector, right? Now k1 dot r, this is k1 dot r is going to be, this is going to be k1 sin theta x, k1 sin theta x minus k1 cos theta y, right? And similarly k2 dot vector r is going to be k1, because k1 equal to k2. Okay, k1 k1, because their k1 equal to k2, right? Because their wavelengths are same, coherent waves. Okay, so k1 minus k1 sin theta x minus k1 cos theta y. Okay, now we'll put the value. Very good question, guys. We'll put the value. So now E1 and E2 are given, right? So E is going to be E1 plus E2. Okay, electromagnetic wave equation. So E is going to be E1 and E2 is right, this, right? E1 equal to this, E2 equal to this, and K1, K2. And now what we are going to do, we are going to add this, and also we are going to put value of K1 dot R and K2 dot R, right? These values are this. So E is going to be Z cap A e to the power iota omega t. Okay, and this is going to be e to the power minus iota k1 sin theta x minus k1 cos theta minus k1 cos theta minus k1 cos theta y. Y plus e to the power minus iota minus k1 sin theta x minus k1 cos theta y, right? Adding E1 and E2, it is going to be okay. Next point. So now it is given y equal to 0, right? For plane y equal to 0. So E is going to, we'll put y equal to 0 in this expression. So it is going to be z cap a e to the power iota omega t, and y is going to be 0. So it is going to be e to the power iota k1 sin theta x, right? Minus iota, and plus e to the power iota k1 sin theta x. Okay. Now the value of theta is given, right? Okay, before that this is the case, right? Minus k1 sin theta and k1 sin theta x. Okay, next is and now we'll find I intensity, right? I is going to be E1 star E, right? And this is E. E star is going to be z cap this e to the power I omega t, and we'll replace iota with minus iota, right? This is minus iota, this is plus iota, this is minus iota, E star, right? And I'll write E star first. E star is going to be z cap a e to the power, will replace iota by minus iota, right? Minus iota omega t, okay, into e to the power iota minus plus, the minus will be plus, right? Plus iota k1 sin theta x plus e to the power minus iota k1 sin theta x. Lengthy calculation, but very good question. Okay, so now we know total intensity is going to be E square, right? Intensity, right? And that is E star, E square is E star E, right? So we'll put, this is E, this is E star, right? We'll multiply this. So this is going to be I is going to be A square, z cap is going to be this one, this is dot, okay? These are vector, right? So this is dot, E star dot E. So z cap is going to be 1 e to the power, it is going to be A square 2 plus e to the k1 sin theta x plus e to the power minus iota 2 k1 sin theta x. Okay, so now since theta equal to 30 given, right? So I is going to be A square, and we'll place theta, we will replace theta by 30, right? So this is going to be A square 2 plus, this is going to be e to the power sin theta. Sin theta equal to 1 sin 30, value of sin 30 is 1 by 2, 2 get cancelled. So it is going to be e to the power k1x plus e to the power iota k2x, okay, minus iota k2x, right? So now we'll multiply by 2 and divide by 2, we can do it, right? So this is going to be I equal to A square 2 plus cos k1x 2 plus cos k1x, right? A square 2 will take 2 common, so this is going to be 1 plus cos k1x, okay? this value is cos k1x. Okay, and now this is 1. So now for maxima value of cos k1x should be equal to 1, right? So this means cos k1x equal to 1. So this means k1xn equal to 2n pi, value of n equal to 2n pi, right? This is cos 2n pi, sorry. Cos k1x equal to cos 2n pi, cos 2n pi. This means k1xn is going to be 2n pi, right? So xn is going to be 2n pi upon k1. So similarly, we can find x plus 1. X plus 1 is going to be 2. Will replace n by n plus 1, right? Pi upon k1. This implies that is beta, fringe spacing. Beta is going to be xn plus 1 minus xn, right? And this is going to be, if you put value, this is 2 pi upon k1. And 2 pi upon k1, we know that is lambda wavelength, right? And that value we have been given, that is 0.5 micrometer. So this is the value, right? Which option is matching? Let's see. Very good question, and option D is matching, guys. Okay? Very good question, guys. Next question we are going to solve. Next question. This is also a good question. Okay. Which of the following question is which of the following? These are questions from electrodynamics. Okay. So this is, and the previous question which I have solved is from electromagnetic study, right? That is interference of two electromagnetic waves. Okay. So now, which of the following is not a correct boundary condition at the interface at an interface between two homogeneous dielectric media in the following and gap and gap is a unit normal vector unit normal vector to the interface sigma and Js vector are surface charge and current densities. Respectively. Okay, and options are: option A is n cross n cap cross d1 minus d2, okay, equal to 0, and option B is n cap cross h1 minus h2 vector equal to Js. Option C is n cap dot d1 minus d2 equal to sigma, and option D is n cap dot b1 minus b2 equal to 0. Okay. The question is, which of the following is not a correct boundary condition at an interface between two homogeneous dielectric media? In the following, n cap is a unit normal vector to the interface, and sigma and Js are surface charge and current densities respectively. Okay, so we need to find which of the following is not the correct boundary condition. Okay, so I'll solve it now. Since given, okay, since media is homogeneous dielectric, okay, media is homogeneous dielectric, okay, since media is homogeneous dielectric, this is given, right? It means we'll assume uniform polarization and magnetization. Assume uniform polarization and magnetization and magnetization. Okay, so and sigma and Js are the free surface charge and free surface current density. Okay, so this means del cross D, curl of D is going to be 0. This implies D1 parallel to D2, and curl of P, this is polarization, is going to be 0, and This means d1 perpendicular minus d2 perpendicular is going to be equal to sigma. So this implies d1 minus d2 vector is going to be sigma n cap, okay, and n cap, or we can write n cap d1 minus d2 equal to sigma, right? And this implies we can write n cap cross d1 minus d2, okay, n cap cross d1 minus d2, this is dot, okay, this is dot, and similarly we can write n cap cross d1 minus d2, right? Will not be equal to 0, right? This wouldn't be this cannot be 0, right? So in option A you can see it is given n cross n cap cross d1 minus d2 equal to 0, okay. So but from here we can see that n cap cross d1 minus d2 cannot be equal to 0, means option A is the correct option. This is not the correct boundary condition, okay. So option A is the correct option, okay? Option A is the correct option, okay. Next question. Question third. Question third is it is also a good question. The permittivity tensor, the permittivity tensor permittivity tensor of a uniaxial and isotropic standard Cartesian system, Cartesian basis is permittivity tensor, okay, that is 4 epsilon 0 0 0 0 4 epsilon 0 0 0 0 0, okay, 9 epsilon 0, sorry, 9 epsilon 0. This is the permittivity tensor of uniaxial and an isotropic medium, okay, so which is uniaxial and an isotropic medium, where epsilon 0 is a constant, epsilon 0 is a constant, epsilon 0 is a constant. The wave number of an electromagnetic plane, wave number of an electromagnetic plane wave polarized along x direction, polarized along x direction, polarized along x direction, and and propagating propagating along the y direction, or propagating along the y direction,